Right, and we're back at it again for the 3 people that are interested. Thanks to all the people who've liked and subscribed. At the moment you can see in the lathe there is a bar of steel being held by a lathe steady, which I had made. I tried buying one but couldn't find anything suitable, so I had to make one. Piece of steel in the lathe. I'm just facing it off and putting a centre in the end of it, which will be useful later on for milling the splines. Some information on the steel I'm using. It's 8620, which is a nickel chromium molybdenum steel alloy. That can be hardened by carburizing, so very much like case hardening. But so basically it is heat treated, it's heated up, red heat, and it then absorbs carbon into its outside skin, making just the outside skin wear resistant, and the combination of the two things is supposed to give very tough, resilient drive shafts or gears or other mechanical parts made with that particular steel and process. I'm not convinced I'm going to be hardening it. I have bought some casing it type material, which you basically heat it to cherry red. There's also a product called cherry red, it does the same thing. You heat it up to this cherry red, you then apply this material, you heat it again, then you quench it, and that then turns that high carbon steel coating that you've put on your part to be super hard. You can also then stick it in the oven and heat it to a certain point to sort of relieve that a bit. As far as I understand, the only thing I am worried about is doing this at home. Am I going to end up warping the shafts? It's not that hard to do. If you quench it not right, you will end up bending. Still, those steel shafts are really big and damaged. I doubt that will happen, and I'm just doing the ends, so I'm only going to quench the ends. Probably get away with it, but I am a little bit nervous over the heat treatment. So you just see me there, face off the end of the bar, put a centre in the end. Now, close-up shot. Video work's not amazing. I'm trying to get better at this. I'm thinking about different cameras and ways of doing things and stuff, but let me know in the comments if you've got any ideas. This is on the CNC mill. It's going back and forth doing the splines. The CNC for this is absolutely awesome because it takes out the getting tired and just indexing the wrong amount and end up ruining the shaft and out with dodgy splines. So this just does its robot task of going back and forth, machining the splines. It's worked very well. I had a few niggling problems with it in the start when I was doing earlier shafts, but I've got over all of that and I'm very, very happy with it. It did the shafts on, well, the splines on both ends of both shafts absolutely fine. And here we go, is a wide shot of the same thing happening. And whilst this is happening and I'm happy that the program is working properly, I can literally walk off, leave it alone, tidy up the workshop, go and have dinner, whatever. It's all working reliably and quite happy with it. Well, I think that's enough of me talking, so I'll leave you to watch the rest of the machining. I hope you enjoy. Many thanks. And for the shafts, I turned the bars down from the 50 down to 33mm, so that's a little bit wasteful, but getting material to do, I couldn't really afford to buy a bar of 50mm and a bar of, say, I don't know, 40mm or whatever, so getting that one size of bar probably worked out probably the cheapest option. But hopefully over time I'll build up some more stocks of better materials. Now I'm getting more into making, I don't know, better parts perhaps. I'm trying to get hold of more interesting materials. Getting sort of, well, trying to get a better knowledge of materials and material science, although there's a huge thing to get your head around and probably never live long enough. So there's the other end of the drive shaft. That goes into the outer constant velocity joint. That now needs a groove to take its spring clip in that end. And those are just basically knocked on and knocked off, or pulled on and pushed on and pulled off. There are tools you can get for clamping the drive shaft and applying pressure to actually pull the constant velocity joint off, which is much less destructive. I'm just checking that everything still fits. That is just held on by friction, if you like. It needed a knock with a hammer to actually take that off. So I think I've got the fit of the splines quite good. They don't rattle about or anything. Yeah, pretty happy with that. Right, does it fit? Yes. That's actually very good. That'll have to do.